Question 1 involves an exercise device that uses the compression of a spring. We're also given a graph of force against compression for the spring, and in A part 1 we're asked to state Hooke's law. Well, Hooke's law states that extension is directly proportional to force as long as the limit of proportionality is not exceeded. In part 2 we need to state which two features of the graph confirm that the spring obeys Hooke's law over the range of values tested. Well, the graph is a straight line and passes through the origin. In part 3 we need to use the graph to find the spring constant, stating an appropriate unit. Well, from the equation the force is equal to the spring constant times the change in length, we can rearrange as the spring constant is the force over the changing length, and this is the gradient of the graph. So we can put in the values of 450 newtons, giving a compression of 0.35 meters, and this gives a spring constant of 1290 Newton meter to the minus 1. In B part 1 we're given the formula for the energy stored by the spring as a half times the force times the change in length. We need to explain how this formula can be found from the graph of force against extension. Well, the work done in stretching the spring, and therefore the energy stored in the spring, is given by the force applied multiplied by the distance moved. This is given by the area under the line, and this is a triangle of area half base times height. This leads to half the force times the change in length. In part 2, the spring is compressed by 0.28 meters in 1.5 seconds. We need to use the graph to find the average power developed. Well, the energy is half the force times the change in length, and for 0.28 meters, reading from the graph, we require a force of 360 newtons, giving an energy of 50.4 joules. Power is work done or energy transferred over time taken, and so we've transferred 50.4 joules in 1.5 seconds, which is a power of 34 watts.